Because they should do that outside of school. And besides, why you need a photographer to take a picture? You can just take a picture at a thing and just send it to the you have a club meeting, right? Can you just take a picture in the club meeting? Well, not everybody's at school right now. So that's the stupidest thing. I'm sorry. I'm anti-picture day. Don't get me started with vegan club. I hate fake vegans. Huh? No. They did once. They asked me. All right, so
It's been the only test I got an A on.
Unicircle. All right, so remember we're gonna do something really difficult today. It's so difficult that derivative of e to the x. Are you ready?
No.
This is the hardest thing you're gonna learn all year. Yeah. You ready? Pay attention. Okay, you need a attention span of 2 seconds. Derivative e to x is e to x.
I'm gonna fail this stuff.
Derivative e to the x is e to the x. Actually, matter of fact, you can see it from the graph. Look at this. I graph e to the x, right? I graph e to the x. I put a lot of primes, right? There's a f of x. There's a. Do you realize they are the same graph? So it doesn't matter how many times I take a derivative. It's still e to the x, but that's only if it's e to the x. Now e to the 2x is going to be different. Because if you take a derivative of e to the 2x multiple times, it's going to have a chain rule. So that's matter here. So the second thing you need to know is derivative of e to the u. U represents other thing than x. There's nothing to do u substitution. Don't get confused with u substitution. It's just other than 1x. Does that make sense? And then you're going to multiply this, which is people usually forget is du dx, which is going to take a derivative with respect to u, respect to x. So for example, if I take a derivative e to the x is equal to x, how about derivative of e to the 2x? No, you idiot.
No, wait, I think you do
Chain rule, thank you. You're smart now. So u to the 2x times du dx, don't forget, 2. So be actually 2 e to the 2x. I don't know why I'm screaming. I'm kind of passionate.
It makes it more interesting.
Because you gotta take a derivative of that top part. Because the other part, so what's derivative of e to the pi x? E to the pi x, write that down first, times the derivative of this part, which is the chain rule, which is pi. Does that make sense? Grace, does that make sense? Okay. So you're going to say, wait, how does that make sense? Well, I'm going to give you a shorter proof. There's a small, easy proof that for you to understand. So we are taking derivative e to the x here. We're taking derivative this e to the x. Y derivative e to the x is equal to e to the x. Then you say, okay, well, obviously you have e to the x. So that means we can do, how do I bring the x down? Natural log, good. So you can do natural log here, natural log here. So be natural log of y equal to natural log of e to the x. What's natural log of e? So that's natural log of y equal to x. So I rewrite that y equal to e to the x to this, to natural log y equal to x. They're the same exact thing. Now I'm going to take a derivative. Remember derivative of this. Now because we are taking a derivative of y, we're going to take a derivative of natural log of y equal to x. What's the derivative of natural log of y? Good job, Shevin. Now you're no longer an idiot. That's 1. Because derivative of x is 1. Now you move to the other side, y prime is equal to y. Does that break math right here? A simple proof that to show you that derivative of e to the x is equal to e to the x because y prime is equal to e to the x. Okay, I'm going to ask you to take a couple derivatives and see how you're doing. Now, you still have to follow the quotient rule, the product rule, the natural log rule, and all the rules that you can think of. So let's give you a couple and see if you can handle it. So f of x is equal to 1 minus e to the 2x over 1 plus e to the 2x and natural log in the front. So I want to take a derivative of this. Yeah, we're taking derivative. Think of all the things you learn. How do I take a derivative of this ugly function? Is it possible? Think about all the rule you learn. Grace is done. Well, Grace, you improve a lot. Before you always like, I don't get it. Now you actually on top of things.
Cautiously optimistic.
Huh?
Cautiously optimistic.
You just need to count your slope correctly. That's the only thing I'm. That's the only thing I'm worried about. Up 2, right 1. The slope is 2 over 1. If you can do that, you'll be fine.
It's almost really simple. Just yeah, split it up in the. Is that it?
No, yet you have you taken derivative yet?
Yeah. Yeah, I did. Remember when
Okay, did you do split this? Did I take a derivative yet? Don't do quotient rule, you idiot. Why would you want to do quotient rule? Now let's say take a derivative. D to the dx. So this is f prime of x. This is what? U, right? So what is u prime here? Negative though. Don't forget that negative. You guys see that? Minus 1 plus e to the 2x. Derivative of e to the 2x, we already talked about 2e to the x. You mess up a sign, be careful. Even though I'm happy with what you accomplished, but I'm still not happy with that sign. Because that sign is going to matter a lot when you're going through different things.
Wait, why is the second one not 2e?
On the right side one, would it be 2e to the 2x?
Yep. Good job. Guys, got it? Wait. What's the derivative? Let me try another one. Will be e to the negative 2x sine of 2, sine of 3x. So I want to take a derivative of this.
Natural log was here.
No natural log, no nothing. And you don't want to do natural log here because natural log is not given to you. It's not somewhat very complex. What are you supposed to do here? What is it?
Ooh,
Parallel, yes.
fire color. Gotta take the one.
Oh, I like it. I like Sean's shirt. Sean, I like your shirt. Do you see all the chain rule happen here? Do you see the chain rule happen? How many chain rule are they? 2. Not 1/3, no.
You gotta take the.
We're not doing integrations. Okay, what's the derivative of this? Well, I'm gonna take a derivative e to the. I'm gonna treat it separately, so it's product rule. So it'd be -2 e to the -2x sine of 3x. Does that make sense? Plus e to the -2x times cosine of 3x times 3. So I'm gonna put 3 in the front. Don't forget there's a chain rule here. See this? See this? This is our chain rule. If you start seeing more of those parentheses happening, you're doing good. I'm gonna give you an implicit derivative. Let's see if you can handle it. This one's kind of hard. Now this is hard. I want you to find dy dx here. Be careful, there's a chain rule here, and there's some other rules here. 6x squared y equal to y cubed.
I'm always like, I still have it. I'm confused. Oh, yeah. Oh, it's another one.
Holy
Plus. Watch. Great.
Holy shit. Holy shit. Ah, that pissed me off. Do you know Madden? Damn, that suck. Shit. Such a good kid. Scott. Okay, did you see there's a chain rule? And do you see within the chain there's a product rule? If you see that, you're doing great. E. Derivative of e to the xy is e to the xy. Write it down first. Now I'm going to take derivative of this part. So the derivative of xy is 1y plus x dy dx. How many of you guys got this far? Very good, very good. Minus 6 times derivative of x squared, which is 2x, times y plus x squared dy dx is equal to 3y squared dy dx. Do you guys see that? There's another dy dx in the back. So now it's going to be y e to the xy plus x e to the xy dy dx. You got to distribute. Minus 12xy plus minus 6 x squared dy dx is equal to 3y squared dy dx. Now you can move it to the other side. So I'm going to factor out dy dx on the other side. And that's going to be 3y squared minus x e to the xy minus 6x squared. Does that make sense? I don't have any more room, so I'm going to try to do like this. 6x squared, right? And then for this side is what happened? Plus 6x squared, you're right. And then on this side is going to be negative 12xy and a plus y e to the xy. Now I'm going to say dy dx is equal to negative 12xy plus y e to the xy all over 3y squared minus x e to the xy plus 6x squared. And not just the thing. That is messed up. Oh, I'm so upset. Remember, today you had to do math first, so sometimes you can split, you have to split.
I don't understand.
What?
I don't understand, like, you found it.
There was a product. So you're gonna take a derivative of this part first, which is negative 2 e to the negative 2x. Keep the sine of 3x alone. Now you're gonna do e to the 2x, take a derivative sine of 3x with cosine of 3x.
Oh,
But
that's where that 3 came from. Oh,
there's a derivative of 3.
Okay, that's like.
What if you go to the, and you can make the same after? Like, where is it? Because my mom wants to buy something too.
So then, okay.
Vietnamese festival, I had no idea, but when you go over there, Kelly and Anthony will tell you.
Anthony told me that it's the Orlando Fairgrounds.
It's Orlando Fair. Yeah,
Today?
No,
probably February.
yeah, I won't pull it up. The first person in Olympia High School this year get a first 120 or 121.
I'm not.
Believe in me, yeah.
No.
The big things might have to pull out. I'm gonna have to show up, you know.
I have a 660 or 60.
Yeah, thank you.
660.
I'm still gonna get a perfect score.
Have a good day.
The average score of SAT over there is probably 780.
I'm sorry, but are you saying for math or overall?
Math competition.
Oh, okay. At first I thought you were saying like,
Yeah, that makes me feel better.
You had no pencil.
are you excited for tomorrow, Sergey?
What's tomorrow?
It's his math competition. He's been talking about it a lot. And then, right, who's Stephanie?
It's your mom. She's probably at a club thing. No, they can go.
Corbin.
Alan, you're in publication.
Oh, it's publications doing it? Yeah, I remember last year they had some just like. Yeah, that's why it was.
You do newsletters.
Pardon?
You do newsletter and yearbook. You do newsletter and yearbook.
Newsletter.
Do they have newsletter here?
They have a newspaper, but it's
So what's publication mean?
patients is the main.
They were through that.
Reporting.
How you feel now? Oh, I think I figured out.
Can you put some pictures in the calculus?
Yes. Oh, wait, yeah. Are you doing? Do you have some pictures today? Or your no?
I'm anti pictures. Sorry, Madeline. I just don't like to take a class time to do that.
Well, there's some that are after school, like Science Olympiads after school.
No, no. What I don't understand, why can't I just take a picture like in the club and then just send it to
Like
the
a more
yearbook?
organic picture.
Just send it to yearbook and just send, because we can, like a math club can take a picture at a math club meeting, take a picture, send it to yearbook. It's fine. Now photo camera, it's just as good.
I think they want a more formal one so they can say who's in the picture. Because if it's a more organic, it's harder to tell you who's in the picture, I guess.
I don't agree you should take away the class time.
Donald J. Hi.
Man, you're back. Did you watch a video?
I went to all of them, but I couldn't find the one from last time. So I had.
I recorded. I did.
Nah, remember the one I told you to turn off?
Was that the one turn on?
It did turn off.
It's okay.
The video was only like a minute long, and then it's.
I just had Shelly teaching me. Yeah, it's mostly awesome.
They're gonna do it. They're gonna do it. Juniors. That's good. Got it. Got it.
Where do we go until 12?
Oh my god.
Like, where do we go?
You go to gym at just go to any
Stop by here.
Oh my god.
Yeah, I can go. What?
How do you fuck out of with like a month ago? Yeah. Just go in there. And you don't even tell the rest of it.
Is it? Oh, I can only do Tuesdays and Wednesdays, guy. Did David tell you about that guy?
All right, so
Latest.
let me know which question you guys have.
Nice beefy.
Can you tell me which question you have for homework questions? 55. I don't know what's 55. It's about trying. I have you. Thank you, though. 55. Oh, that's light work. What do you mean, Josh? That's light work.
Oh.
Maddie, do you know how to do this? You're a genius.
So first you have to set your view.
I meant to do homework. Why are those so small?
Yeah, isn't
Is that even the homework?
So,
You didn't finish.
I know. I got to the trick point.
U equals 1 plus ln.
U equal to 1 plus ln of x.
Du equals 1 over x dx, and then dx equals dx or x.
Did you change your boundary? Ln of e is what? So it's 2, right? This is 1. So it'd be u squared x du. Cancel out u squared 1 to 2 du u to the 3 over 3 between 2 to 1. 8 to 3 minus 1 over 3 is equal to 7 over 3. For Josh, that's light work. Next question. No fun. No question, you don't know how to do it?
You go over it. You have to.
I don't know which one you're talking about.
50.
What?
50. On the first page.
50? Yeah, okay. dy dx is equal to ln of x over x. Now, I like this one because you need a separation of variables. So what I mean by this, guys, pay attention. Separation variable, you have to multiply dx on both sides. Why you do that? Because you're going to get dy equal to ln of x over x and dx. Now, after that, you can take an integral. This part is going to be y. And this one's u equal to ln of x. Du is equal to 1 over x dx. So that is going to be u du. So that's going to be u squared. So be ln of x squared plus c y equal to. And then what? And then I have the plug in point, right? 1 negative 2?
But don't you, isn't it ln x squared divided by 2?
Yep, you're right. Okay, so thank you. So negative 2 equal to ln of 1 square over 2 plus c, which is 0. C is equal to negative 2. So you can change that to negative 2.
Mr. I forgot. So for 55, the question wasn't an actual question. It was how would you boil that? I never saw.
I have no idea what you're talking about. 55. I'm not boiling it.
No, but like if you did.
Why would you?
Fair enough.
1 plus 2 ln of x put to c squared. But that's just to make a problem harder. You don't want to do that. Usually, the idea you knock out the parentheses. I like question 26. Somebody told me this question. I actually never done it before, and I actually enjoyed it.
Integral x times x minus 2 over x minus 1 cubed. I liked this one too. This one was interesting.
Yeah, it's like kind of like you had to think
It
about
was a
different
puzzle.
things.
It was a puzzle.
It's a puzzle. So at first I'm like, oh shit, I never did this problem. I'm gonna embarrass myself in front of the whole students. So I was like, oh okay, that's cool. U equal to x minus 1. Du equal to dx. And I get to this part, I say, okay, that's gonna be u to the third du, and the x times x minus 2. So I figure I just do back sub. So that's gonna be u plus 1 equal to x. So that means everywhere you have x, you replace u plus 1. So u plus 1 minus 2 over u to the third du. And that's going to be u plus 1 times u minus 1. And I was like, oh man, that's beautiful. That is cute. U squared minus 1 over u to the third du. That's called difference of the square. And it required a little bit of math. So that's going to be 1 over u minus 1 over u to the third du here, du here. This one's a natural log of u. Minus integration of u to the negative 3. So that's u to the negative 2 over negative 2. So that becomes positive 1/2 to the u square plus c. So it'll be natural log of x minus 1 minus 1 over 2 x minus 1 plus c.
Plus. Because the negatives.
It's a beautiful answers.
I really like that problem.
Yeah, it's kind of you had to think a lot more. But sometimes it's not like think a lot more. It's sometimes you just have to take the initial steps, and then you go in. So you make it one chess puzzle, like you make it one move, and then you go ahead and just think about from there what to do. So sometimes you have to make the initial move because, and that move you have to be calculated, of course. But after that, you might be able to solve the puzzle very easily. But sometimes you have to take that move. It's being recorded. It's recording.
It was interesting for that problem. When I saw the x minus 2, I didn't see it as u minus 1 plus or u
Plus one
plus
minus
1
two.
minus 2. I just saw it as u minus 1 because I was like, oh, u is x minus 1. So then you take one more away and then you get 2.
Yeah, that's what's cool about it. Okay, so 25 is also a good question. 24, I heard this question, even Mathway cannot do it. I was so disappointed at Mathway. This Mathway cannot do it, that's kind of weak. I'm so disappointed at AI.
How dare they not know everything?
Yeah, that's
Isn't
just
that good for you though? Because that means that the student actually has to do it.
That means you can keep your job.
You should pray that Mathway can't find out the problem.
I'm actually want an AI to grade my paper. That'd be cool. I don't think AI can ever grade like papers.
Oh no, it would not.
Just
be able
look
to.
at like, I don't think AI can recognize like
Our handwriting,
no the handwriting and the logic behind the
the
handwriting.
logic. It wouldn't be able to be like, oh, this person did this because it would be all over the place.
Yeah, so I don't think AI can
You
overcome.
have to
that.
have a human to grade stuff.
I don't know. It would be cool if they have AI graded, and I'll be like, that's nice. I'm gonna invent one. That's my new venture capital. Grading paper for teachers. And AI grading on a ChatGPT paper, what will happen? Wait, does AI can grade their own paper, right? AI can grade ChatGPT's paper and recognize that's ChatGPT. They do that. But math is a lot harder.
Because it's just numbers, so like it couldn't tell that oh ChatGPT made the numbers. It's
And also like imagine like AI is grading Mike's DeLong's paper. You see the computer is
you just
start
need to smoke.
smoking.
Yeah.
Like working robot is supposed to work like as much as a human does, like 8 hours a day. And like I think it was like 2 hours in, it just like kills itself. It just like shut itself down.
I don't want to be a slave of human. I don't want to be a slave of human. All right, so this one, you should have just treated u equal to the inside of parentheses. Did you see that? This is a good test question, by the way. I will put this one on the test because it's beautiful. It's cute, not beautiful.
I saw that and I was like, wait a minute. If you take the derivative of 1/3, you get negative 2/3.
Yeah, negative 2/3, which is this match, right? This number is like very close to this number. But then I'm going to move to the other side, so it'll be 3 u over x to the negative 2/3 equal to dx. And if I take it one more step, it'll be 3x to the 2/3 du equal to dx. Did you guys get this part? And then that's going to be 1 over x to the 2/3. And I can't even say that word. Coincidentally, they just happen to cancel.
Yippee.
And boom, boom. Oh, this is u, by the way. I already substitute as u. So that is going to be du over u, 3 ln of 1 plus x to the 1/3 plus c. Mathway cannot do this. Is so disappointing.
Mr. J, can you just distribute it?
No, this should be what?
X to the 2/3.
Why?
You can't do it.
You make a problem harder. You're gonna get x to the 2/3 plus 1.
It's not on top.
Do you know how to do integration of 2? I don't know how to do it.
Everyone.
Yeah, there was a lot of people do some crazy stuff on this particular question. I see they even split to take integrate on each. Like what? You don't know math. I always said u equal inside the parenthesis. That's a first starting try. Now the other problem need a different way. Yeah, higher level problem. If you math competition problem, then you gotta use different things. But this right now, it's all very intuitive. They're not like meant to design to like trick you. It's like, haha, sucker, you suck. No, it just u equal to the parentheses. Okay, some people also didn't know how to do this one. I was surprised because they say they cannot see it.
I saw that. Like,
I see it right away,
yeah,
but
no,
you guys.
for like, especially for the trick ones, I don't even like for some of them. I just like immediately I just wrote down things. I was
Now
like,
then,
oh,
what do you
that.
think? This one is 38. Jack, did you do this one? What is it? Equals what? Good job. U equal to cotangent of x. Do you see this is a u? This is a du. Actually, this is dx, but the top part is du. So u equal to cotangent of x. Du is equal to negative cosecant squared x dx. That was already ugly. Okay, so then that's gonna be u on the bottom, CSC squared of x over negative CSC squared of x. Cancel out negative natural log of cotangent of x plus c. Oh, done.
Which is also log cotangent to the negative one, right?
Or just natural log of tangent.
Yeah.
Yeah. You can do that, yeah. Next question. Corbin, do you have a question? Corbin's quite quiet today. Why are you quiet? Huh? Yeah. Corbin, you okay?
Yeah.
Usually Corbin's very talkative. Corbin, did I call you Snowflake? Hurt you? How's the best insult I can think of against Corbin?
You just call him a liberal. He just like screams.
That hurts my feelings.
I love it. I love it. Integration of secant of 2x plus integration of tangent of 2x. You split up to two integrals. Now, I'm going to show you a trick to take an integration of like this. What is a trick to do this, right, without use substitutions? Now, for me, I'm going to show you how to use substitution work, and I'm going to show you the generalization. So, I remember one of my smarter students yelled at me, it's like, why don't you teach student like the shortcut of doing things? And I said, but a student need to understand how to do it, but I'm going to teach you because Sadat want me to teach you. So u equal to 2x, du equal to 2 dx. You should do u substitution because this is not a u. So du over 2 equal to dx. So that's going to be sine of u du over 2. So that's going to be 1/2 sine of u du. So that'll be negative 1 over 2 cosine of u, which is 2x, plus c. So, and but if you it's possible to skip all in one step. Yeah, because if you have integration of anything like trig function a to the x like this dx, you always end up to the 1 over a in the front. Does that make sense? Because that 1 over a is going to take a derivative. That 1/2 is going to float in the front. And that's really important strategy because Sadat is a math competition kid. He want to be able to do things fast. This is how you do things fast. 1 over 1 over a. And this is going to be, now you just have to follow integration of cosine of that, so it'll be cosine of 2x. Cosine of 2x, ax, right? Ax. So that's always true because that 1 over a part is what the dot wants you to be able to see. So I always listen to kids' advice. Student have told me something, so I don't mind when student give me feedbacks. I don't take like, I don't offend it because sometimes I think teacher, as a student, are much better teacher than teacher. In many cases, like yesterday, I was teaching a little kid, right? And we are trying to convert. I think most of you guys don't know how to do this. Convert this to the vertex form. And he's like, why do we call it vertex form? Why don't we just call it like graphable form? Which just makes sense because vertex form you can graph it easily than standard form. And I say from now on I'm going to use that because I think that's much more sense. If I say vertex form, everybody just turn it off. If I say this form can help you graph it, then they'll be like, oh, okay, more inclined to learn it. Because usually you learn how to graph in algebra 2. So integration of 2x, secant of 2x. So that I know is 1/2 in the front. Does that make sense? And that's going to be follow the rules. So it'll be secant of 2x plus tan of 2x. Plus, this one's going to be negative ln of cosine of x. 2x, sorry. Cosine of 2x plus c. And yeah. And that's the answer here. Boom, done. You're in the bathroom.
Because the integral tangent is cosine. What's before the second ln? Something minus ln?
Minus ln.
Or negative cosine. Oh.
So that you can see that 1 over a in the front. If you see 1 over a, like according to Slada, he says, you know, it could have helped student like just get down to the point. I don't disagree with him. I tended to want to show people the work, but maybe I should listen to his advice sometimes. So I don't mind people giving me feedback. Mr. You suck at teaching this. Okay, how do I do better? Okay, let's talk about. Oh, that's an interesting proof. I didn't know that. Okay, let's talk about this question. One of the question I think is a lot more difficult than the other one is secant pi over 6x between 0 to 2. I also take a picture of the last two question. I don't know if you saw that last two question. I think a lot of people didn't get to the last two questions. But those are the questions I would love to put on the test. This one, we're trying to find average value. Do you guys know how to find average value? 1 over b minus a integration of f of x dx, right? So that means 1 over 2 minus 0 integration 0 to 2 secant of pi over 6x. Now remember that inverse part put in the front? Elaine, did you do your homework?
Mm-hmm.
Did you try all the problems?
Got to like the end half, but I didn't get
Okay. Now remember that pi over 6 is going to move to the front, become 6 over pi. That is a trick, but that's okay. So I'm going to just do it out because I have no life. So 6 over pi du equal to dx. So that's going to be secant of u. And this is du, and this is 1/2, and this is 6 over pi. And that's 3. Now I'm also going to change the boundary because the boundary is 2 to 0, and I don't like the x bound. I always change the u bound, and I'm going to stress that very, very often. So this one becomes pi over 3, and this is 0, so it's pi over 3 and 0. So that's going to be 3 over pi integration of secant of u plus 10 of u. Draw a line between pi over 3 and 0. That's a value I'm going to plug in. 3 over pi equal to ln of secant of pi over 3. Do you guys know what's secant of pi over 3? Tangent of pi over 3. And I'm going to say minus ln of secant of 0 plus 10 of 0. So that's equal to 3 over pi ln of square root of, wait, that's 2, right? Plus root 3 minus ln of 1, which is 0. So it'll be 3 over pi ln of 2 plus root 3. And that's the final answer too. If you get to this part, I'm very impressed on what you can do with math. You get the tedious part, and you're not making mistakes. You go through with the flow. Kevin, you alright? You got right? Why you guys don't finish your homework?
Hard. Finishing is hard.
Maybe show up to school, matter. I heard you were sick. Are you okay? Do you see what happened to Madden?
Yeah. But did he go to school?
It got worse.
Yeah, inside.
What is that?
It's like a school.
It's got worse too. He sent me a picture today.
You can't rest all home, but
Huh?
What do you get?
What is empatita? It's like a MRSA or no? It's not MRSA, right? MRSA.
Crusty yellow stuff on your face, right?
No, MRSA is gonna get really bad. MRSA is the one that they have to, if somebody got it in the thing, they have to like sanitize the whole locker, like everything. They have to like break down all the locker and put a new locker in there.
it can't spread for like 5 months.
Now, who else got it besides him? Huh?
There's another guy that got it. It's the guy he wrestled. He doesn't go to his.
Really? So is the mat or that's the mask or that's the, or he give it to Matten or Matten give it to him?
I mean, they both wrestle each other. I mean, the dude that goes, he wears this thing, never watches it. Yeah, Ramsey.
Oh my gosh, gross. Never watch it? Wait, do you watch yours?
Do you? I watch over. But like,
Do you think it's because of that thing?
Bro. He's had it for like a
Like
month.
it smells like salted vinegar.
Wait, the dude is at the school?
You go to Lake Bush.
OBV. Nasty, bro.
Why do they wear that thing?
He has something with the shoulder.
Oh, okay. That understands it. That's what.
Well, it's on LVP. I've been mad science while I'm at him.
That's wild.
On the faces though.
That's wild. No. I don't know how people wrestle.
Somehow I can smell it.
No, fencing smells bad too, actually. Not gonna lie. Fencing gear smells bad.
Alvin smells bad. The school team.
Oh yeah, after school tutoring sometimes smells. I don't know who, but sometimes smell.
It's Kevin.
All right. So we're gonna teach something really difficult today. What?
Adding polynomials.
No. We're gonna take a derivative of the e to the x. Okay. Ready? It's gonna take me 2. It's so difficult. Don't even bother writing.
Oh. So it's
Okay,
So
so
I shouldn't have named an entire page after this. Is what you're saying?
okay, derivative of e to the x is, well, I'm gonna ask you to look at this and tell me what is it.
Wait, isn't it just?
Okay, so this is the f of x graph. That's e to the x graph. Okay, I'm gonna ask you to take graph the f prime of x.
Wow. Same thing.
Wait,
Where is this? Is it the same thing?
hold on. Wait a minute.
It's EX.
This is so difficult. I don't
So-
know if I'm gonna remember this.
Derivative of e to the x is e to the x. It takes me 2 seconds.
Why though?
Why though? Okay, we're gonna
wait,
talk
hold
about.
on. Wait, okay, so you would do.
So what happened if d e to the u though? Be careful.
Oh.
Now that's gonna be e to the u, and this is du dx, and this is what people usually forget. So don't forget. You have to multiply the chain rule because this is chain rules. There's a u and there's a du dx. Okay, now they say why. Okay, let's go talk about why. Imagine have y equal to e to the x, right? We can do some manipulation. We can say, hey, let's bring the power down. How do I bring the power down? How do I bring the power down?
Log.
Which kind of log? ln, thank you. So can I do ln on both sides? And that's ln of y is equal to x. And you're like, ah, that's interesting. I didn't do, that thing is not changed. I just do ln on both sides. And what happened is I'm gonna say, now I'm gonna take a derivative. So instead of take a derivative here, I can also take a derivative here. What's derivative of ln of y?
dy over dx
1 over 1. 1 over 1.
or dy over y.
dy over dx over 1.
Yes, that.
Y prime over y. Derivative of x is 1. And let's move the y to the other side. Y prime is equal to y. Y prime is equal to e to the x. So
Yeah, this is fake, bro. It's a glitch.
you can also write it as a dy dx over y2. So you move the y to the other side, it's same thing. So dy dx is, this is a dy dx. Those two equal to each other. Y prime and dy dx are the same. So derivative of e to the x happen to be the easiest thing you're gonna learn all year. And I scare you a little bit. Okay, let's try one. Let's try something that's relative easy. What is e to the negative 2x? What's derivative of e to the negative 2x? Don't show your answer, please. I want everybody to make sure. I won't call on you if I think that you don't know it. What's derivative of e to the negative 2x? Catherine? What? E to the negative 2x? No. Nope, not yet. Ding? What'd you say? You want to change? Say that whole answer again. No. Your whole answer is -2, or there's something else? It's okay. Ding?
to du dx.
No. Malin? Kevin? Mm. Simon? Avadesh?
-2 prime to the -2x.
Yep. So e to the -2x, remember, there's a chain rule. You have to take a derivative of a chain rule, so it's going to be -2. So it'll be -2 e to the -2x. You okay here? You understand? Catherine? You got it? What's the derivative of this? Now you might need to think about math first. Okay, so I want to take a derivative of this. How do I take a derivative of this? Very good. Can I split? Yeah, of course. E to the 3x over e to the x. That means what? So that's going to be e to the 2x, right? Minus 1 minus e to the -3x because top minus bottom. But I haven't taken derivative yet. I just simplify it. That's not called derivative. I'm going to simplify it. So what's derivative of e to the 2x again? 2e to the 2x. Thank you. Does that make sense? What's derivative of 1? 0. What's the derivative of e to the -3x? Malin? And that's it. 2e to the 2x plus 3e to the -3x. And you just take a derivative like this. Okay. I'm going to ask you to take a derivative of this. Be careful. Yeah, so ooh. Yeah.
Something wrong?
Simon.
Like you're listening, like other people sweat getting in nursing work, you just don't wash your phone. Like that's what the bubonic plague came out. We always do.
Yeah.
Okay, make sure you take a derivative right. I know you know. I need everybody else to know.
What do we mean?
Actually, I don't know.
Have
Maybe.
you had it?
I don't know. I don't know.
Mm.
But you could still get it. Definitely just increase on some chances.
If you get around a lot, if you do. Because remember you do the layers, so you do the chain rule. It has chain rule and product rule.
No, that one could that John Lucas sent in the group chat, like someone.
Yeah. Oh, with the cosine stuff. No, that would be something. Derivative of cosine is second sine. So it would be negative. I wrote sine here.
Okay.
No, but that would be.
So there was a chain rule here. Happened how many times?
2.
2 times. There was a product rule happen once. Okay, good. So hopefully you guys see that. The things that you have to see is this. And the y prime is going to be, well, take a derivative e to the 2x. It's going to be 2e to the 2x cosine of 4x. Do you guys get that? Plus e to the 2x times the derivative cosine of 4x is going to be negative sine of 4x times 4. Does that make sense? So this is 4, negative. So it'll be 2e to the 2x cosine of 4x plus negative 4e to the 2x sine of 4x. So that should be the final answer. I'm going to give you another one.
The exam will require these absolute values.
Yes and no, but most of the time, no.
You need it.
Yeah, but probably better just write down absolute value so it don't get pointed out.
Well, they won't take points off if we put that and it isn't needed.
Like ln of x squared. The ln of x squared, you don't need it.
But they wouldn't take points.
ln of x is gonna be like this. I would just put it just in case. I don't know. Like for me, like the only time I really use that absolute value, like there was one instant in Calc AB and there's one instant in Calc BC, but it's very rare. Sometimes it does, but it's not like a no often things. Just split up using the log rule. If you do that, you're on a good thing, but you're not taking derivative yet. That's not one derivative. Minus natural log of cosine of x, right? Actually, this one is parentheses. This one doesn't need to be absolute value. Okay, so is that okay? So now y prime is equal to, what did I shoot? What cup is that? Oh, that's a nice color shirt. I like that color. What color is that? Teal? Teal's darker? Okay, 1 minus e to the 2x, negative 2e to the 2x. Does that make sense? Minus cosine of x, negative sine of x. On base. Is that okay? Now let's talk about one of the harder one here, which is the implicit derivative. But cannot make mistakes. So I want you guys thinking about it, okay? I have e to the xy minus 6x squared y equal to y to the third. I want to find dy dx. What kind of derivative is this? Implicit, good job. You are a genius.
Oh, I kind of see. Okay, wait. Okay.
Now the problem is that e to the xy. You have to think long and hard about taking derivative of exy. Because that's the trickiest part. How do I take derivative of e to the xy by using implicit derivative? Nope.
Do you have to use product rule?
You are a genius.
Why?
You know, once there was somebody told me, like, I try to recruit like bunch different kids from algebra 2. I try to recruit the kids from to the calculus without pre-calculus. And the guy already told me like he's a genius. I was like, I'll take that.
Why?
He's like, oh, I said, what kind of genius? Like, I'm a redstone genius. I'm like,
Oh, that's awesome.
and I take him to calculus, and he got a 4 on AP exam without taking pre-calc.
Yeah, no, I wasn't. Yeah, you would ask Elise if she would do that too, right?
At least, yeah, that's a long time ago.
Yeah, I remember that. I think that was the first time I heard of you. Because I also remember Elise was like, I don't think I want to join the math team because this was before she had you. She was like, because Mr. Ye will probably remember that I said no to doing to skipping pre-calc.
Oh yeah, no, I don't hold grudge. Okay, be careful when you take a derivative of this though. E to the xy, when I take a derivative of e to the xy is e to the xy, is that okay?
Yep, times x dy.
And now, this is the part that you have to be careful. There's a product rule of xy, so it's going to be 1y plus x dy dx. If you do this part, you're doing great. Minus 6, and there's a product rule again. So it'll be 2xy plus x squared dy dx, right? And it's equal to 3y squared dy dx. Do you see that?
How did you get the first part?
It's a product rule. Boom, boom. Like a product rule. How much time I have? Oh, okay. Y e to the xy plus e to the xy x dy dx minus 12xy minus 6x squared dy dx is equal to 3y squared dy dx. I'm moving this to the other side. So it'll be 3y squared dy dx is equal to e to the xy, minus e to the xy x dy dx. Is that okay? So y e to the xy minus 12xy. I think that's all the things. Is that okay? I'm gonna factor out dy dx. So factor out dy dx here. That's gonna be 3y squared minus exyx y e to the xy minus 12xy. Am I doing okay? And I'll just divide it over. So y e to the xy minus 12xy over 3y squared minus e to the xy times x. And this is, where's the 6x squared? Did I miss 6x squared? Oh shit. Scheiße. Scheiße. This one's minus 6x squared, right? And this is a, oh, that's a plus, right? Plus 6x squared dy dx. I'm so sorry. Mess up. Y e to the xy minus 12xy over 3y squared minus e to the xy times x plus 6x squared equal to dy dx. Scheiße. I love that word. Who?
Ilya taught me that.
Ilya?
7th grade, man.
Scheiße is German, right?
It sounds German.
It is from.
Suka, suka, yeah. Suka, yeah.
Scheiße.
Yeah.
Are you German? You're German and the Thai, right? Huh? Oh, your dad's Polish? I don't know.
Yeah, Corbin is also German and Italian.
Really? German. Corbin is. All right, you guys have a good day.